We're ready to start.
Not so much.
I'm sure all of you know I'm Jan Curtis. I'm a retired meteorologist, worked in the Navy, and retired from the Navy. And I've been I've worked in 2 universities as well as a climate researcher. And I was also a state climatologist in Wyoming for a couple of years back in the early 2000s. And I've had quite a variety of experiences in the public sector. But when I had spare time, when I wasn't moving around as much as I was, especially in the military, my number one hobby was definitely not weather, but astronomy. I just fell in love with it. And one of the nice things about it is that you can do really well without even a telescope. And everything I'm going to show you today is just taken with a telephoto lens on a 35mm camera. And with the digital age, you can shoot a lot of pictures without it being that expensive once you get through the initial cost. In the old days, and I do have some photographs, although I didn't digitize them, of comets in study that were definitely inferior as to what I could do in this technological advanced age that we have. So what I did was I went to Quark AI, which is online through X, and asked it to give me a listing of the brightest comets in the last, well, since 1957. And I took 57, even though I was born in 52, to see which ones I missed out on and which ones were the brightest in either hemisphere. And it turns out that if you take an average, comets, really bright comets that get the notoriety in the press, probably occur once every 10 years on average, but there could be 20-year, 30-year gaps, and then you get 2 or 3 of them in just a 10-year period. So it's like it's kind of an odd thing. We just went through a 5-year period where we had a nice comet in 2020, comet Neowise, and then the end of 24 in October we had Atlas A3. I'm not going to say the Chinese name part of it. So what I want to do is, most of the data here is fairly accurate. I disagree a little bit on the maximum length of the tails of the comets, and it's a big difference what the eye can see and what photographs can pick up. So I think the AI gave me kind of a fair estimate. I challenged it on its readings, and it apologized, but for the most part, it's a fairly accurate depiction. Now, when it says maximum, it's up there in one of the columns, maximum magnitude, most of the time people don't see the maximum magnitude because it's pretty close to the sun. In 1965, I have a funny story, comet, a CAS wound up being, they have here minus 10th magnitude. I think it was more like minus 15, but it was about a half a degree from the sun. And that particular day when it was closest to the sun, I remember specifically, it was 13 at the time, blocking the sun with my roof line, and it was fairly clear sky, and I could see the comet as just a bright arc. It wasn't a straight line because it was in the process of curving around the sun at the time, so the perspective was really odd. But I would say that the magnitude was at least minus 15. It was just remarkable, and it would have been impossible to photograph because of the dynamic range that's involved. But ironically, I thought that was the day that it was going to be visible rising from the sky, in the morning sky. So a friend and I went up on the roof and waited, and there was nothing. And I never went back a couple of days later when it finally emerged from the sun, and missed out on seeing a 30 to 40 degree tail. It was kind of a big disappointment. But then again, in the later years, there was Comet Bennett in 1970 in March, which was really the first close to 0 magnitude comet. It says it was 10 degrees the tail. I'd say it was at least 10 to 15 degrees. And it was a very simple comet in the sense that it didn't have much structure, at least naked eye, but it was a really slim, beautiful object. And I can see it from Brooklyn, New York. And that's pretty remarkable. In fact, I woke up my parents. I was at another house. I woke up in the middle of the night to look out the window to see the comet. They were actually trying to keep the light away from doing that. 1976, there was Comet West, which was another very nice comet. Had a lot of structure to it. I was in the military at the time, and I couldn't really get very many good shots from that. And going down the list, there was in 2007, everybody who's into astronomy can remember that comet. Let's see, 2007. It was not McNaught. It was what was the one that just was a big globe without a tail?
Holmes?
Oh yeah, it was Holmes. That was it. Holmes only got it got down to 2.4 magnitude only because it had started fading and then it just erupted with an extra flare for a couple of days, and it was about the size of the moon, or double the size of the moon in diameter, and it was just a big glowing thing in the sky.
It's cool.
I missed that one, but fortunately, as you'll see, I managed to capture some nice ones since then. But I wanted to show you a little bit of the techniques that are used for comet photography using PixInsight, and then showing you comparisons between the comet, tracking the stars with the comet drift and all this type of stuff, removing stars from the background. There's a lot of little techniques that really bring out the issue. Well, this is Comet West from Fairbanks, Alaska in 1997. And I only show this picture with, you can see the aurora in the background. I used film in those days and did camera. This comet was visible naked eye easily for 4 months. It's just the most remarkable comet. And I'm sure the magnitude in this picture was probably close to zero, if not zero. And one of the co-discoverers, there's Bob, saw this on the internet, and the internet was only around for 2 years. That was publicly accessible, not through the universities. And he asked to use the picture for a roadshow that he was going around touring. So that was kind of nice. Unfortunately, he died 20 years later at a fairly young age, but it was kind of one of these nice memories. I kept the email that he sent me at the time, and I lost it.
The same Bob as in Hale Bob?
Yeah, same one. And Hale's still around. Now let's go to this one. Oh, this is oops. I guess we should do it this way. This looks like Holmes a little bit.
A little bit.
Yeah, this was a comet that was visible in 2018 in December, and it was called. I think it was linear or one of those. It was barely visible to naked eye. I was down in Arizona, southern Arizona, when I took this for a period of about 2 or 3 weeks. It was just on the verge of visibility, and I was in a boreal 2 or 3 zone, so it was pretty dark. And in this particular picture, you really got to use your imagination. But off to the side, going left, the 9 o'clock position, there's a little bit of a tail, maybe, and it shows up better in different platforms showing it. But these are the types of things. Sometimes you look at a comet, it's very disappointing. The faintest comet I ever saw that actually had a real distinct tail was about 9th magnitude. Usually by that distance and faintness, you just see it basically a smudge, nothing really defined. But that one was particularly pretty impressive. But this is a comet that had an outburst. Again, I don't know if it's important to tell the years, but this was in 2017. Or this was actually July 2018. Up on the screen, you can read those small letters. And this was an outburst that I thought was very interesting. You could barely see the tail in it, but the color green was the most vivid color I've ever seen. And you can tell that it's not phony up because the star colors, again, doesn't quite show up as well as on your Mac, but it's realistic. And I try to keep everything as much realistic as I can. And then this was a famous comet called ISON, named from the observatory, just where they discovered it. This was in 2013. This comet, unfortunately, was a sun grazer. And for about a week, it became naked eye visible, and had nice little structure streaming and so forth. And this is 4 days later, just before it went into the sun. And it was unfortunate that it couldn't survive because it would have been another IKEA safety, I think. But this was like one of the last pictures ever taken of it. You can see the twilight is already emerging. And these things move fast. When we're going to the sun, they can move easily the diameter of the moon, half a degree or a degree in an hour. So they could get a series of pictures with enough exposure. But I did actually see this one naked eye. And usually it's got to be at least fourth magnitude, pretty close to the horizon of twilight to be able to see it. It's one of my better ones. And then sometimes comets are very interesting. This is a comet that shows both the dust and ion trail. Look at the size of that ion trail. That's the thing that's headed up. Here's the dust tail. The ion trail probably extended 12, 14 degrees. And this was comet Catalina. And this was in 2015. And I think I actually took this one in Cheyenne when I first moved here in 2015. And what was interesting was throughout the series, and I'm not going to show you this, all this stuff is available online through my Flickr account. I have several comet albums as well as with the bright comets and then general comet pictures. I probably have over 200 of them. And each one has a story about the exposures and some stories behind them. But this one was very interesting because in the course of a week or two, the angle between the two tails changed. It got compressed. Most times when you see an ion tail, it's pretty much parallel to the dust tail. There's a little bit of the offshoot of it, and you'll see it with comet Neowise later on. It's really, really interesting how it changes over time. Now here's an example. This was a comet ZTF in 2023, not that long ago actually, and this was in June. And here's an example where I try to get different types of perspectives of the same image. Basically, with stars and the comet stationary, there's no stars with comet stationary. And this is where the, I guess, you can see some star trailing there, so obviously, but this was with PixInsight showing kind of an inverse image. Sometimes contrast and seeing detail is a lot easier against a white background instead of a black one. And I think the last one is the stars are fixed and the comet isn't. You can see it's a little bit more blurred. And then what I did was I went through this sequence. I won't spend much time, but these are each more or less every day. I had a good streak of clear weather, and I basically tried to duplicate everything. Maybe the orders of the things are different, but just notice how this is another day. And what was interesting about this picture is I had a book on cometary forms that was a pictorial book of showing what comets looked like in the 1880s, 1890s. With astronomers, they didn't have photographic capabilities. Yeah, but they sketched them out. And I always thought they were exaggerated, but if you can look carefully, you can see the tremendous amount of detail that's in there in the black and white version. And it's quite remarkable. And you can see that as long exposure, even with the stars blurred out a little bit. You can see that this is probably a 2 or 3 hour exposure, keeping the comet fixed. Okay, let's see. This is another day. Yet another day. You can see the angle of the streams or the two tails are changing over time. And then I have a sequence here. That shows here's the 27th, 28th, and then the 2nd. So it's a couple of days apart. You can see the angle how the comet structure totally changes. And it's because of the perspective of where we're looking at with respect to the sun and Earth, the angle of it. So it kind of gives you an indication of that. So that's why every time you go out every night, even though it's a bright comet, you never know what to expect. Some nights it's very quiet. Other nights it has a detached tail through turbulence with the solar winds. It's very, very fascinating. Okay, this one is Lovejoy in 2013, in November. Ironically, a year later, Lovejoy had another one that was spectacular. And two of them, these were photographed down in New Mexico, near Santa Fe. And here's an example. This was the 11th of November. This is the 29th of November. Big change in the structure as it got closer and closer to the Earth. And you can see, again, it was moving fast. That's why the star trails are what they are. The most ideal comet to photograph is ones that don't move very fast. You take a long exposure, you don't have to stack them. It doesn't happen very often, especially when they're close to the sun. And this is now December 13th. And it's hard to believe this is the same comet. This is December 31st, 2013. And again, the conditions, every night when you take a picture, there might be clouds up there you don't know about, very thin clouds, and it can really affect the transmissive nature of what your sensor can pick up. Now this is the Comet Lovejoy in 2015. This is in January. And what I did was, I actually made a Sky and Telescope and a couple of other astronomy magazines. I sequenced these pictures so that almost every day I was clear. In this particular case, there's a period of 1 week. Starting from that side is the oldest picture, and then it gets newer here. And you can see how the tail kind of oscillates a little bit. And at the time, I didn't realize, well, the comet wasn't moving very quickly. So what I can do is basically take a number of exposures, and the comet drifted a little bit. Later on, I learned that it's worth sacrificing the stars to get the structure of the comet being still. That's the key. Using PixInsight to work that takes a little bit of extra steps to fix the comet from your first photograph to your last. But it's,
it's a pain in the butt.
It's a pain in the butt, but it obviously is worth it. But it's and this is a couple of days later. Again, a sequence of 5. Now it's interesting. The screen here is showing them as blue, but the true color was more of this lighter green color. There's a little bit of tweaking in the monitor, but you get the idea. And I'm really more interested in the structure. So look at a little number of rays coming off of that one. And this again is another period, probably a week later. This is already in January, and this is the one that got into various magazines. This star is the second brightest star in Andromeda. It starts with an A, AM myth or something. And it's the second magnitude star, so you can see that the comet, again, naked eye, I really had a hard time seeing it. It was directly overhead, or pretty close to it, and it's just amazing what the sensors can pick up with it. But
There's a lot of blades on that lens.
yeah, there is, isn't there?
Are those like 1 night apart, each one of those?
Yeah, each one is almost 24 hours apart. So you can see it was drifting. We're not talking about this field of view is 7 degrees by 5 degrees in this orientation, so it's not moving very quickly. The tail, again, if you look at the monitor, it shows it extending much further out. This is probably not the best way to describe it. Yeah. Now, this is I think one of the last sequences. This was on the 7th of February to the 14th of February 2015. And here, you notice the stars are kind of fuzzy. It's because I decided to try the technique of keeping the comet stationary. And you can see, especially the wiggles in the tail and forking. And here's a discontinuous break. And then the solar winds hit it. And you can see the structure is completely different. Here it's very linear, and here it's very diffuse.
So how do you keep the comet still? Are you tracking on the comet, or are you just
No,
taking
I
really short exposures and then registering them on the comet rather than on the stars?
Yes. that's essentially how it goes. It again depends on how fast the comet's moving. But normally I find that if you can go more than 90 seconds without the comet being blurred, go for it. But most of the time,
To get the structure,
that's the key. But I like if
90 seconds is a long time.
Yeah, it's a long time for a comet for most of them, especially when they're close to the Earth. They're kind of zooming by. And what I wanted to talk about with comet Hale-Bopp was the year before there was a comet. Well, it was about the same. Was it about a year earlier? About the same time. It was the Hyakutake, or
Yeah.
I can never pronounce the name of that
I think
comet.
it's Shaku
Yeah. This comet was a remarkable comet. I was at the 65th parallel, north latitude in Alaska, and I can't believe I didn't photograph it. The day it was closest to the Earth. It was 9 million miles away, and in a matter of a minute, you can actually see against this background stars the comet moving. But what was most remarkable, it wasn't a real bright comet in a sense. It was probably second magnitude, but the tail extended almost 100 degrees across the sky.
Watched it flip around.
I was on this dirt road in the middle of nowhere in complete darkness, and it was freezing cold even in March in Alaska. But it was just such a remarkable sight to actually see a comet moving. Without maybe I didn't take pictures because I couldn't. It was moving so fast.
Yeah, that's good.
But it was amazing. And using averted vision, I could double the length of the comet for what I can see. And I can see where if you took a photograph of it, 100 degrees was a piece of cake for that one. But imagine only 9 million miles from the Earth, and it's that large. So imagine in the context of the solar system, that thing had to be hundreds of millions of miles long, And it's like, holy moly, this is from a little dust
I
sample.
can't remember. I know there's a Soho image of it that's filled the wide field fills the field of view, and I think it extended past Mars.
Yeah, I think so. Yeah.
It's just amazing.
Yeah, it was just a remarkable comet, and Hale-Bopp got more notoriety because it was brighter in the naked eye, even in big cities, for such a long
You could see
period
it for
of time.
what, 2 years?
Oh yeah, well, in the naked eye you can see it for it was 4 months, and it's normally we saw the comet this past October. Well, the full moon didn't help, and I'll show you a bit of Atlas A3 afterwards. But
I was on an airplane, and the pilot,
pointed out.
he actually did it a 360, so
So
people on
people
both
see-
sides of the airplane
Oh,
could
wow.
see it. And it was just
Yeah,
there.
it was
and it was
there.
so easy to see. It was,
Right.
that was kind of the coolest thing ever.
Yeah.
Nice.
So anyway, in fact, this is a comet in October of last year. It was about the first magnitude, at least the nucleus was. But unfortunately, full moon really ruined this one. This could have been a spectacular. I'm not complaining, but you can compared to Neowise, this was Little Orphan Annie. I think is the best way to describe it in comparison. But I'll show you some pictures of it. This was Neowise. I think the first day I could see it, we could see it with twilight. And then this is the second day when it developed the anti-tail, which is
There's
pretty
a bright
remarkable.
detail too.
Yeah, it was. They claim it was as nice as the one that was with Aaron Rowland in 1957. You can see the star trails. The thing was moving pretty fast. Even I think I could take only 20 or 30 second exposures even at this time, and it was receding from the sun. But still, this is without stars, and you can see that the anti-tail was just amazing. So what the anti-tail is basically is a perspective thing. You're actually looking at the comet, but at an angle where it's really hard to describe, but it's like the comet is three-dimensional. You're only seeing it as 2 dimensions here. It stretches out quite a distance. So what you're seeing is that stretched out part in line with the orientation of the comet, so that it gives that little faint extra tail. I'll show you an example where you have 3 tails because you have the dust tail, the ion trail. Really, some people could see it later on in the evolution of this thing. And then you have the anti-tail, so you actually have three separate tails with totally different natures to them.
The ion trail is opposite the sun, right? And the dust trail is along the path of its.
I believe that's the
Orbit.
case. That's right. That's right.
So I'm looking forward to trying this, but I think blur exterminators correct only will whip those stars into shape, and then you can remove them much better.
Right. There's
So
there's
I think there's some tricks to,
Yeah.
because I can still see like
Yeah.
they're there.
They're
Right?
there. If you're
Yeah.
trying to get rid of them completely, you're tapping into the
Yeah.
structure, and it's really difficult. And that bright object up there at the top is actually a Messier object. I think it's
It was
M3.
M3.
Yeah. So, and this was the next day, and the sky conditions here in October were not the most ideal. Besides the moon, there was a lot of bit of high clouds in there. But I think that detachment, you can see there's an expansion of the tail at the top. I think that was just a little perturbation that ran along the tail as it was going. This was the next day. You can see it's really fading, but I started getting the greenish color into it. And this is the next day. And I don't know if you can see, it moved too fast to see from one day to the other with the star trail. So maybe here. I was thinking if you can see this little star trail here, this little grouping of stars. What's the next day? It's up there.
Wow.
It's in the tail, so you can see it basically went 10 degrees in one day, the comet, just as a rough estimate. And then, oops. Then there's, this was on the 25th of October, my anniversary. Okay, and then the 26th was my last one. And now we're looking at Neowise. And Neowise was a really fascinating comet because I was down in Arizona in the process of selling my house down there. And it was visible for a day or two down there, and then I started traveling north and getting into darker skies as it's receding from the sun. And I was able to record, I think, out of 2 or 3 weeks almost every single day. And I'll have a little movie that I'll show you about it. But what I want to show you here, this is very interesting. This is the raw image of the comet that I took. And then in PixInsight, they have a thing called Exterminator. First name. It basically homogenizes the gradient in the thing, and you kind of showed that last month.
Raxford.
Yeah, and then watch the top of the tail when I do this. You can see how the background shifted, but the comet itself, it brought out much more detail. And here you can see the ion trail very vividly. And what's interesting is, in this particular case, this is very unusual. This part of the ion trail, you see it's kind of got a reddish orange tinge to it. They feel that the gases that created it, since it's ion, it's actually sodium. And it's very, very rare to see in an ion trail. So this was an exceptional comet, even though it wasn't the brightest comet ever seen. It had characteristics that were making it one of the great comets of all time, because it had synchronicity bands that I'll show you in a bit. They were really spectacular to see. Now, naked eye, you can't see them. I've got to be honest that what the eye picked up and what the camera picked up were very different. Because when you look at the sky, you don't see that many stars. So it's just the nature of the sensor, but it's still very fascinating that you can do that. And here's just an example for perspective. This hill is about 3 degrees above the horizon, and this is almost due north. And this field of view is, I think this was with the 85 millimeter lens. So it was essentially 10 by 15 degrees. So it's 15 degrees across, 10 degrees high. And you can see easily it gets to the very top there without a problem. So it's, again, it's 1 degree above the horizon, artificial horizon, but it's really 4 degrees above. And this, what was nice about this comet was it was circumpolar. It basically went below the horizon barely. If you were up in Canada, you could see it all night, actually transiting and then coming back up. So you had an evening comet and the morning comet. You could watch it continuously through the day, through the night. So it's kind of a nice feature of it. Now this was a single exposure. This was, I think, let's see, I don't know if I have it on there. I thought it was about a 60-second exposure. And this is a wider angle lens. You don't see the star trailing as much. And then I decided to stack them. And look at the difference when you stack a picture. But again, it was a little bit cloudy. You can kind of see the bands in the sky there. It's just can't avoid that. But it was kind of a nice setting to see a comet like that. It was pretty remarkable. And I wouldn't have taken the picture if I didn't really see a lot of this to begin with. So it's not like I'm fabricating or just imagining, well, let's take the picture and maybe we'll see something. No, it was quite visible, and it's pretty dark skies north of town. And here's this was an angle, this picture. Some people really like that glow. I'm kind of distracting, but look how nice and blue the ion trail is. And if you look really carefully at the tail, top of the tail, you can see the banding in there. And that's the synchronicity banding, which is, again, very rare. Usually it only happens with comets that are 2, 3, 4 times brighter than this one. And then here's another day. You can see how it changes the shape and the structure of the dust cloud, the dust band. Changing the orientation gives it a completely different feel too. It's kind of interesting in that regard. And here's another day. I was very fortunate. I almost had every single day I could view it at one time or another. And I'm going to show you a movie that's quite spectacular that shows what I'm talking about with the circumpolar effects. And then as you can see, as it receded, everything kind of started dimming in the structure of it. It was getting more and more lost. And this was the 26th. I think this was the last one. Maybe one more. Nope, that was it. So what I want to do now is I want to go to two movies I want to show you. They're short time-lapse clips. If I can find it, I should have done that. I might need your help. Where was
You can
it?
go to, so drag the mouse down to the bottom.
Bottom, okay. And this folder, download, no,
It's not there.
it's in here. Oops. I didn't move it.
You lost your screen.
Oh, what's my screen? Oh, no.
There you go.
Oh, okay.
The cable got pulled out.
Oh, is that what happened?
Well,
The
either
HDMI
the
cable.
HDMI cable, yeah.
Oh, this thing.
There we go.
Okay, so,
Oh, it's an SD card.
yeah, it's the SD card.
Oh, you got it.
Did you do it?
I was need to find the external drive.
Oh,
People would come to visit us on my my kids' friends, you know.
Go to Finder.
And now
Oh,
they
there's
come
this
and call me and
miscellaneous.
ask me.
Oops, I missed.
Mr. Miscellaneous. And then, okay. Well, the first movie, there's two short clips I want to show you.
Yeah.
This is Pan Star in March of 2013. And this is a most amazing image. It's probably once in a lifetime capture of a comet setting with a very thin crescent moon. And I had a lot of acclaim on this one. Again, I was in New Mexico at the time when I took this, but when you see it, it's pretty remarkable.
Time lapse.
Yeah, it's a time lapse. And you can see the moon. You can barely see the comet. It's up here. And now watch, it's kind of eerie the way I did the time lapse. Start it and move it out. Now watch what happens. This is kind of neat. It's kind of weird.
That is awesome.
Isn't that kind of neat?
Very cool.
Do that again. Yeah, it's,
Play it again.
yeah.
Maybe end it now.
So, yeah, you can see the Earth sign on the moon. It's pretty large.
Yeah.
It's probably a 2-day moon. But the comet was, you see very close. And it was very interesting that it was fourth magnitude at the time. I could barely see it with the naked eye. I mean, I was trained to see it because I had a good reference with the moon. I could kind of tell the distance. What happened was, a couple days later, in darker skies, it became a spectacular comet, but I couldn't find it.
You didn't have the moon?
No, I didn't have the moon. I think that's what it was. I knew kind of where it was, and I didn't have any star tracking device. That's why I did it this way. This one I did for some reason, but the later ones, I just couldn't find it. And people were bringing in pictures. I said, this can't be the same comet. And it was one of my, and the weather wasn't that bad where I would have missed out on it. I tried 2 or 3 days, and I just gave up, and I said, nah, it's nothing going to happen. And I didn't follow up on it. And sure enough, it became really a spectacular one. So that was one of my big misses. But at least I caught this pretty spectacular moon set. And then this is the one on Neowise, and I set it to some kind of interesting music. It's I think the guy is a Russian composer, some new age kind of music. But it's kind of no, you'll see what I mean. Let's see if I can make it larger.
Yeah.
It's right there.
Yeah, I know. I'm hoping that will show up. And the music comes in. Yeah, here it goes.
Crazy cloud, man.
There are a lot of crazy ones. These are taken each day apart, and I think I don't see the dates on them, but I thought I had the dates. But they're following day after day every time you see a new sequence. This is still obviously the first one.
You can see it moving relative to the stars.
Oh, you can. That's interesting too. So you can see it just skimmed the northern horizon. And eventually it got into this was the morning event. Eventually it got into the evening event, and then I could follow it through the morning. Yeah, you're right. I never really noticed it. It's kind of subtle.
You kind of
Now
pick a star.
this is evening setting, and then it swings around to the morning.
You can see it's not quite.
Now this is it. This is coming back up to the east. I have that band a lot. Don't I?
Yeah, the cloud being
Yeah.
interesting.
Kind of weird.
There's your name all over.
Yeah. You can see the comet into deep twilight. Now here's an example where I changed the exposures as it got darker and darker. I kept on giving it more light. And you can see the tail kind of growing and getting brighter. This is just again a factor. There's clouds.
There's your cloud.
Yep, there's the cloud. There's coming down. You can almost see where the house is almost due north. So it's set about a degree or two below the horizon at the time. And the clouds dissipate. I was lucky, a lot of days. I got a couple of good hours in it, or nights, I should say. See, even then there was a lot of stuff in the sky, satellites.
Satellites are airplanes.
It could be both, yeah. I had a neighbor that had that damn light.
That's what a 22 pistol.
Yeah, I know. I think a 45 is probably more
It's a
around.
long ways to shoot, though.
Yeah, it is.
You got feet, don't you?
22, 250, just sit back behind a tree and take a shot.
So that's my presentation, and just wanted to show you that you don't have to really be sophisticated, have sophisticated equipment, or be very knowledgeable about what you're doing when you take a time exposure. You see something in the sky that you can see, invariably it's going to be much more enhanced with the digital capabilities that would be censored. And what's true is when you look at the northern lights, it's spectacular. You can see a lot of motion in, a lot of detail, but when you take a still picture of it in a couple seconds, the sensors are sensitive to different wavelengths of light, and it just brings it out as a completely different animal.
Yeah.
And people, I mean, give them more power, it gives them a background for the landscapes and things like that. And it's bright enough, the aurora, for example, that it illuminates like a full moon, what the night would look like, but in color. You know, it's just something that people exaggerate in the sense that they say, "Yeah, I saw this," but they really didn't see exactly what the camera picks up. But is that legitimate? It's always a question. Sometimes they want to enhance. Well, we want to see more greens or more reds in it, up it a little bit because it's digital. You know, to try to be as realistic as you can could be a disappointment. You got to give it a little extra flair. It's a matter of taste and your techniques that you use.
It's also a matter of trying to actually remember what it looked like.
Well, that
because
is-
with the digital, you can make it look any way
Right,
you want.
and I do that too with sunsets. I mean, a beautiful red sunset, your eye's seeing it, and the camera's seeing something not quite the same. And,
Pretty much entirely different. Yeah.
but I try to, when I take a lot of sunrises and sunsets, that I try to keep it as close to realism, and yet aesthetically, the camera, in a way, is the initial pictures that the camera takes isn't necessarily up to par with the eye can see. But then what happens is you enhance it, and it becomes better than what the eye can see. So it's a matter of trying to find that balance where you're not cheating the system. And if there's guilt that I have as a photographer, it's that. It's how far do you go? And it's been,
What is the truth?
what is the truth? I mean, yeah, there's a lot of subjectivity. But
It's actually harder with digital because when the
Right.
camera's doing its white balance setting and your computer's doing its white balance, it can completely throw off the total balance where it's nothing like you saw.
Right.
And it's actually nothing like it recorded because you can monkey with it so much you can completely distort the colors.
Exactly. So, does anybody have any questions about Comets? Or a couple of months ago, if you were here, there was a presentation with the guy who is, I think his title is Mr. Comet, and he just lives for every single comet that ever comes up, and he follows it through the entire time that it's in the solar system, whether it's faint or not. I think because of technology now and the constant monitoring of the skies, the number of comets that are discovered or rediscovered have quadrupled in the last 50 years. And my goal, and actually one of my bucket list things that I'll never have, is to discover a comet and have it. Comet Curtis, it's kind of a catchy name. I had one time where I was in New York, in Brooklyn. I was only about 10 miles from JFK Airport. And in those days, they had these jets that fly over without sound compression. And I think my eardrums probably suffered greatly because of that over the years. You can even smell the kerosene fuel or whatever it was. Probably caused cancer later in my life or whatever. It was pretty bad. But I mean, the vibration, if you're watching TV, there's a 30-second, 45-second period, you just might as well, can't turn it up loud enough. It was that loud. The house would shake, these things coming in. But one day I looked up there and I saw this weird thing, and it was like, am I imagining it? It was like, it was out of place. It was a fairly dark night for New York, and especially in those days when they didn't have all the sodium and mercury vapor lights out. But so I got my telescope out. I had a little Tasco 2-inch telescope, 2.5 inch, and I finally, it was kind of moving around. I said, "What the heck is that?" So I looked through it and I said, "Oh, it's a UFO," And then it was a kite with a tail it got stuck in some tree, and it was distant, quite distance away. And I just kept watching it going back and forth. And I said, well, that was
Comet Curtis.
Yeah, Comet Curtis. So,
World famous.
yeah, I almost got on that one.